In the next 10 minutes, I am going to explain how to calculate saturation current for a PN junction in forward bias if current and voltage is given. Also, if a diode cross-section area is doubled, how to calculate the voltage that yields a current of 1 milliampere. Next, we'll see if a parallel combination of PN junctions are placed, how do we prove that the system acts as an exponential device. Obviously, we'll also calculate the current division. And finally, we will explore if the two identical PN junctions are placed in series, how do we prove that this combination acts as an exponential device? With that, for a tenfold change in current, how much voltage change does such a device require? So now let's start with the 14th question. It says to obtain a current of 1 milliampere with a voltage of 750 millivolt, how should IS be chosen? So IS we need to calculate. We know that the diode equation I equals to IS exponential of VF by VT. VT will be 26 millivolt at 300 Kelvin. Plugging in these values we get so IS will be 10 power minus 3 by exponential of 750 by 26. It's 2.966 into 10 power minus 16 ampere. This is part A. Now let's do part B. They're asking if the diode cross section area is now doubled. They told area has been doubled. That means IS will also be doubled because IS depends upon the area of the cross section. Okay. So what voltage yields a current of 1 milliampere? We know that I equals to IS exponential of VF by VT. I is 1 milliampere. Now IS is 2IS exponential of, we need to find out the voltage, and this is 26 millivolts. Plugging these values, we should get 10 power minus 3 by 2 into 2.966 into 10 power minus 16. Okay, this is equals to 1.68 into 10 power 12 equal to exponential of VF by 26 millivolts. Applying law on both sides, this is 28.15 equals to VF by 26 millivolts. So that is equals to 1. So VF will be 0.731 volts. Okay, now let's go to the second question. They say that figure 2.40 shows two diodes with reverse saturation currents IS1 and IS2 placed in parallel combination. We need to prove that the parallel combination operates as an exponential device. So they say that these two diodes are connected in parallel. We need to find out that these two operates as this combination acts as an exponential device. We know that for diode 1 equation, it's IS1 exponential of VB by VT. For ID2, it is IS2 exponential of VB by VT because same voltage appears across both the devices. Now I total is ID1 plus ID2. If we common out that exponential term, we get IS1 plus IS2 into exponential VB by VT. So now we see that this device acts as an exponential device because this total current is having exponential term. Okay, now we can see the next one. They're asking to find the current carried by each diode. So okay, the current carried by each diode can be done like this. See, both the diodes are having voltage VB. So VD1 equals to VD2. VD1 is VT ln ID1 by IS1. Okay, VD2 will be VT ln ID2 by IS2. VT ln will be cancelled. ID1 equals to IS1 by IS2 into ID2 will be I total minus ID1. So simplifying this, we get ID1 equals to I total of IS1 by IS1 plus IS2. Okay, and ID2 will be I total of IS2 by IS1 by IS1 plus IS2. Okay, now this is. So the next question says two identical PN junctions are placed in series. Okay, so we need to prove that this combination can be viewed as a single two-terminal device having an exponential characteristics. So they say that there are two diodes connected in series, D1, D2. We need to prove that this combination can be viewed as a single two-terminal device having an exponential characteristics. For this, the forward voltage should be VD, and for this diode, it should be VD to operate. So V input should be VD1 plus VD2, that is VD plus VD. So VD is VT ln I by IS plus VT ln I by IS, because the same current flows through these two and these two diodes are identical, so saturation currents will be same. Simplifying that, we get 2 VT ln I by IS. So the current flowing through this series is I is equals to IS exponential of VD by 2 VT. So it can be proved that this combination acts as a exponential device, because there is an exponential term in this. So now let's look into the part B. So here VD equals to VT ln I by IS. Okay, so it's 2 VT ln I by IS. We need to find the amount of change in voltage required to get a current of 10 times of ID. So VD dash is equals to 2 VT ln 10 I by IS. So VD dash minus VD equals 2 VT of ln 10 I by IS minus ln I by IS. We get 2 into 26 millivolt into ln 10. So this should give so it's 120 millivolt. Okay, so that's it for today. We'll do some more problems in the next video. Yeah, see you in the next video. Bye. Thank you.